Hello everyone, I am Jayesh Shasawa. This is the presentation on our paper titled Large Language Models for Detecting the Gambling Advertisement Images to Enhance the Efficiency of the Creative Review Process. So to uphold the integrity and brand trustworthiness, the ad platforms have strict policies like no gambling, no adult content, no crypto, etc. So the current process depends on the third-party APIs like Cloud Vision for initial filtering and also on the manual review. So based on our analysis, around 70% of gambling ads were marked safe in our test from the third-party APIs, and manual review seems to be, although reliable, is slow, costly, and error-prone. So we focused on the gambling category. We explored the CNN-based transfer learning using the VGG16. We fine-tuned the pre-trained vision transformer. We also tried multiple approaches involving the large language model, which is the primary focus of our paper. And we tried the ensembling techniques, combining the previous approaches, VGG16 vision transformer and the LLMs. And we did a comparative analysis on FPR, FNR, and F1 score. So we use the Samsung's SSP ad inventory logs for dataset preparation, and it covered variety of gambling images like casino games, real money games, cryptocurrency, gambling, lottery, etc. So we had around 30,000 labeled images, out of which 4% were gambling and 96% were non-gambling. We just like in the real world. We did trend test split, trend test and validation split with 60-20-20 ratio. Here is how the sample gambling and non-gambling images within our dataset looks like. Um, then for VGG16, we tried the transfer learning, replacing the final layer, and handled the class imbalance with the class weights of 1 is to 40 for gambling versus non-gambling. Other details are mentioned in this slide. Similarly, for Vision Transformer, we use the 224 cross 224 base model variant, and we fine-tune on that. So I will discuss the performance of the models later in the slides. Other details are mentioned in the slides and paper. So for LLMs, we did some prompt engineering with help of DeepSeek R1, and we used the Llama Vision 11 billion to classify the images on gambling versus non-gambling. Our results with this approach were not very good. We had around 20% FPR and around 9% FNR. So for our use case and for the LLMs, we tried perform poorly when directly given a classification task. But since LLMs are very good at generative tasks, so for within the approach too, we try to leverage that. So we went through some sample of images. We did the manual inspection, and we also used the help of DeepSeek R1, and we had a prompt ready, which the prompt was to mainly asked to analyze the image based on various gambling cues, etc. So it asks to generate the image description, and this was given to Llama Vision 11 billion model as an input. Along with an image. We adopted the LLM to vet state-of-the-art unsupervised approach to transform the decoder-only language model into a bidirectional text encoder. So it also applies the unsupervised contrastive learning. Basically, the similar sentences are pulled together, and the sentences that are unrelated are pushed apart. So that is why, like, we had to focus on our instruction prompt, where we provided a very good examples of the gambling image descriptions. So we gave the image description generated from vision model and the instruction prompt as an input to LLM2 encoder, and we then trained a logistic regression classifier, logistic regression classifier with Saga solver and balance class weight, etc., on the encoded descriptions against the labels. So here we can see that the Llama Vision 11 billion prompt, we have added some focus areas, like focus on the categories of monetary and financial elements, focus on the game mechanics, playing cards, etc. Then for similarly for the non-gambling images, we have added details. So for instruction prompt, mainly since LLM2 VEC is based on contrastive learning as well, so we had the gambling images descriptions. So here is one of the sample image and response. We can see that LLMs are able to detect the reward word, the fortune wheel, the balloon, the gift boxes. So basically, this can also act as the reasoning to the client on why their creative was rejected. If any business or sales team needs that, but yeah, that can act as a good reasoning as well. For ensemble model, we combined the output propensities of the VGG16, VIT, and LLM to vec model, and we applied min-max normalization and trained the logistic regression classifier on that. So this technique actually improved the results decently. So here are the results for VGG16. We can see that VGG16 perform good compared to VIT. Especially we have less FVR. For approach 2, the LLM to vec-based approach was better among all the three approaches, and its F1 score was around 0.85. Then for ensemble, it was the best, which best with around 1.5% of FPR and 11% of FNR and 0.89 F1 score. So conclusion was, yeah, we decided to still have 5% of the images for the manual review on the cases where the models is not very sure based on the propensities. And for classifying the results that way, we can see that around 95% of the time and effort can be saved. And like we only will have 5% of the gambling images misclassified as non-gambling and around 1% of the non-gambling misclassifications. Other details are here in this slide. Yeah, thank you so much. For any questions, you can reach out to us at the emails mentioned below.